In this video, we're going to be extending the concept from the special product video. In number one, they want us to perform the operations and simplify. Assume all variables represent positive real numbers. In A, we have the square root of x squared, and that is equal to x. So if the exponent and the index and the radical are the same, you're going to output whatever is inside the radical. In B, we have the square root of 3 times the square root of 2 plus 1, all squared. And the index in the radical and the exponent are the same. So we're going to have 3 times the square root of 2 plus 1. In C, we have the square root of x to the fourth. So now the exponent and the index in the radical are not the same. And this is equal to x to the 1/2, all raised to the fourth. And if you raise a power to a power, we're going to multiply the exponents. So this is going to be equal to x squared. In D, we have the square root of 3 times the square root of 2 plus 1, all raised to the fourth. And again, the exponent and the index are not the same. So we have 3 times the square root of 2 plus 1 squared. And you can see that we have a very similar problem in C and D. And when we had the square root of x to the fourth, we outputted x squared. And here we have the square root of 3 square root of 2 plus 1 all to the fourth, and we outputted 3 times the square root of 2 plus 1 all squared. And now we want to use the perfect square trinomial that we learned in the last video to simplify this. So we know that a plus b squared is equal to a squared plus 2ab plus b squared. And in this problem, a can be defined as 3 times the square root of 2, and b can be defined as 1. So we have 3 times the square root of 2 plus 1 squared is equal to 3 times the square root of 2 squared plus 2 times 3 square root of 2 times 1 plus 1 squared. And now we want to simplify. 3 times the square root of 2 squared is equal to 3 squared is equal to 9, and the square root of 2 squared is equal to 2. So we have 18, 9 times 2, plus we have 2 times 3 is 6 times the square root of 2, plus 1 squared is equal to 1. And this is equal to 19, add our like terms, plus 6 square root of 2. In 2, it wants us to let f of x equal x squared plus 6x plus 9, and it wants us to find each function value. So when you want to find the function value at 3, we're going to put 3 in for all the x's. So we're going to have 3 squared plus 6 times 3 plus 9, and this is equal to 3 squared is 9 plus 6 times 3 is 18 plus 9, and that is equal to 36. In B, we have the function evaluated at 3 times the square root of 2 plus 1, and that is equal to 3 times the square root of 2 plus 1 squared plus 6 times 3 square root of 2 plus 1 plus 9. And now we saw above that 3 times the square root of 2 plus 1 squared is equal to 19 plus 6 square root of 2. So we're going to move that down here. And then we have plus 6 times 3 square root of 2 is 18 square root of 2. And 6 times 1 is equal to 6 plus 9. And now we want to combine our like terms, and we have 19 plus 6 is 25, plus 9 is 34, plus 6 square root of 2 plus 18 square root of 2 is 24 square root of 2. And number 3, we want to multiply and simplify 3 plus the cube root of 2 times 9 minus 3 times the cube root of 2 plus the cube root of 4. So we're going to FOIL this out, and we have 3 times 9 is 27. 3 times negative 3 cube root of 2 is negative 9 cube root of 2. And then we have 3 times the cube root of 4 gives me 3 times the cube root of 4. And we have the cube root of 2 times 9 is 9 times the cube root of 2. And then we have the cube root of 2 times 3 cube root of 2. So we have minus 3 times the cube root of 4. And then we have the cube root of 2 times the cube root of 4, which gives me the cube root of 8. And now I want to simplify. So I notice that we have negative 9 cube root of 2 and positive 9 cube root of 2. So they're going to cancel each other. And then we have 3 cube root of 4 and negative 3 cube root of 4. So they're going to cancel. So I have 27. And now I have the cube root of 8, which is 2. So plus 2. So 27 plus 2 is equal to 29. And then it asks us, how does this relate to the formula for the sum of two cubes? So the sum of two cubes could be stated as a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And if we have 27 plus the cube root of 8, that can be written as 3 cubed plus the cube root of 2 cubed, where a is equal to 3 and b is equal to the cube root of 2. And that's our video on extending the concept of the special product.